Okay, let's do some sample problems with cones. We've got some for lateral surface area, then some for total surface area. Remember, we need to know the radius and the slant height regardless of what we do. If we know the radius, we can get the base. If we know the radius and the slant height, we can get the lateral surface area. So here's our equations. So we've got a cone here. Here's the vertex. This represents the center of the base. Okay, this is the perpendicular from the vertex to the center of base. So this would represent the radius. So our R equals 3 centimeters. Now what we need to know is our L. Well, this is a right triangle. This here would represent our L. This is our altitude of the cone. This is the radius of the cone. Well, this is a 3-4 what kind of triangle? 3-4-5, very famous Pythagorean triple. So our slant height is 5 centimeters. Okay? So LSA is simply pi times radius times slant height equals 15 times pi equals, oh, what is that? It's going to be 45 something. So 15 times pi times 47.12 equals 47.12 centimeters squared. Okay? So that's our lateral surface area for that one. Alright? Now let's look at this one. What do we need to know? We need to know the radius. Well, do we know the radius? Yeah, it's 9. We need to know L. Do we know it? Yeah, it's 15. Okay? So we're home free on this one, aren't we? So, lateral surface area is simply pi times the radius, 9, times the slant height is 15 equals. Okay, so let's do that one. 9 times 15 times pi equals 424.115. 424.115 centimeters squared. Okay? Pretty simple way to do that. Now let's go over here where we're going to calculate our total surface area. So what's the total surface area? It's simply our lateral surface area plus our base. Okay? So we just have to find out what the base is. In order to know this, we need to know what our radius is. Our radius here is simple. That's 9 centimeters. Now we need to know what our slant height is, our L. Well, let me see. Got a 9/12. Let's divide 3. Let's divide 9 by 3. What do we get? 3. Let's divide 12 by 3. What do we get? A 4? Oh, this must be a 3-4-5 triangle. So this is a 9, 12, and this must be a 15 centimeters. So this is, again, is 15 centimeters. Okay? Now, let's find our big B. Let's find our LSA. LSA equals pi times the radius, okay, times 15 equals. Well, we already have that down here from this one. So that's 424.115 centimeters. Whoops. 115 centimeters squared. Well, we need to add to that our B, which is pi times 9 squared equals 81 times pi .469 centimeters squared. Excuse me. Our total surface area, we add those two together. 424.115, 678.584 centimeters squared. Okay? Now let's look at our last problem for total surface area. Okay? We're looking at this one right here. We know that the height is 12. We know that the slant height is 13. So let's go ahead and put that down. Our slant height equals 13 centimeters. All we need to know is this radius right here. Well, let me see. That looks like a 12, 13. Wow, looks like a 5, 12, 13 Pythagorean triple, doesn't it? So this right here is going to be 5 centimeters. So our radius equals 5 centimeters. LSA equals pi times our radius, 5 times the slant height. Okay, what does that equal? Let's get us an answer. 5 times 13, whoops, 5 times 13, not 16, 65 times pi, 204.20. 204.20 centimeters squared. What's our base? Equals pi times the radius squared, which is 5 squared, equals, that's 25 times pi, equals 78.54 centimeters squared. Add those two together and we would get total surface area equals 282.74 centimeters squared. Okay? Alright, so there we've got some samples of doing lateral surface area of cones, couple, and doing total surface area. Now for these are all Pythagorean triples, which is very simple to figure out. You need to know those, 3, 4, and 5, 5, 12, 13, 3, 4, and 5, and then you multiple. What is this altitude? If this is a 3, 4, 5, then this must be 12, right here, 12 centimeters, okay? Alright, and this slant height we determined was 5 centimeters, alright? This is another 3, 4, 5. This is a 5, 12, and 13. Okay? And there we have surface area of cones.